and welcome to my workshop here in my home in Bosham, as Arthur said. And thank you very much for inviting me to speak about the robots who ring changes on handbells. And as Susan said, they are behind me. So if I just move out the way for a second, I hope you can see it a bit small, but we'll get a bit closer in a minute. Oh, there we go. There's Rosie on the left and Richie on the right. I started building the robots about 4 years ago, but it wasn't until last year when the lockdown started, and it gave me a bit more time to work on the robots, but in particular, it was the Central Council competition, which they are running every month, which sort of gave me the incentive to get them finished off and get them working. And I entered them into the, I think it was the August competition, which was for ringing not on tower bells. But sadly, they didn't win. They didn't even get a mention from the judges. So they were very sad about that. So I'm going to share with you a presentation, and I will get them to ring, or I hope you can see this. Whoops. Single. Oh. Well, well. Single. Full. Fine.
Oh, Graham, you're on mute at the moment.
Right, hope you can hear me now.
Yeah.
this is the topics I'm going to cover in the presentation, not necessarily in this order. First of all, why I built the robots to start with, how I ring handbells, not necessarily on how I ring the methods, but more in terms of the arm action, how that works, how I built them. Now, 4 years ago, I had very little knowledge of electronics or mechanics. So if you don't know anything about those subjects, don't worry, because I will explain exactly the steps I took and went through to actually build the robots. Nearly all the information I gained was from the internet and mainly from YouTube videos, because there's actually thousands of videos about robots, about electronics and so on. But I did actually have a head start on the computing side, as I worked for nearly 40 years in IT. So computers and programming is something I was quite sort of comfortable with. I said already there'll be some robot demonstrations, and I've also got a few ideas for the future on how to make things even better. So first of all then, why did I build them? Well, I thought first of all it'd be an interesting thing to do. And also I wasn't aware, and I'm still not aware of any machines that actually ring handbells, ring changes on handbells like these. There are machines around who do ringing, such as the Carter ringing machine and the Woodhouse ringing machine. And although these are mechanical, they just generate the changes and they don't sort of swing any bells as such. And of course, they don't have any sort of personality. But the main reason I built them was to practice. I've been ringing handbells for probably nearly 50 years now. And I wanted to practice new methods in advance of starting a peal. And when I'm ringing, I do actually need to see the bells going up and down. It's a sort of rope sight for handbells. There is software around for practicing, and the one that I have used for quite a long time is Able, but I never really got on with pressing keys. About 10 years ago, Graham John imported some hand controllers which you hold in your hands and connected with the computer, and you can ring along with it. But that was fine, but it didn't still do much for me because the graphics on the screen weren't very good at all. So I got now just a very short video of Graham using these hand controllers and using Able. So I'm just going to stop the video there because the second half of it is showing a new software package that Graham also produced about a year ago. This is called Handball Stadium, and it's much better than Able. And in fact, if this had been around 4 years ago, I probably wouldn't even started building the robots because it's absolutely first class for practicing on. You have to use the new hand controllers, which are in the shape of handbells. They're made of plastic, which you can buy. And then you go into practice mode and you'll see on here, and in fact, the graphics are even better now than they were when this recording was made. So that's Handball Stadium. So with any project, we need to have some requirements. And so these are the requirements that I set down. Firstly, the robot should ring any method and composition with the minimum setup time. So if I wanted to change to a different method or ring spliced, it should be very quick to be able to do that. The robot arm action to replicate the action of real ringers, I want it to look realistic. And also for the bells to actually strike at the right time. I didn't want them to be a fraction of a second too quick or too slow. So 4 years ago, I sat down and I remember drawing a diagram just like this. I had in my mind that I would actually have like a box in front of me and there'd be these arms sticking out of the box with a bell on each arm. It was only the concept of having robots sort of came much later. But I wanted some software to generate changes. And then as each bell would strike, it would send some sort of signal. I didn't know what sort of signal, but send a signal out to the arm, which would sort of kick the motors into life and it would ring the bell. Now, the obvious software to use to generate the changes was Able, of course. So I wrote to Chris Hughes, who's the sort of support person. He may have wrote it, I think. And I asked him, I said, would it be possible to change Able? So instead of make the bell sound coming out of the loudspeaker on your computer, instead, could it actually just send a signal, send out some sort of signal that I could send on to my arm? And he said, it already does that because there is a MIDI interface. And MIDI is a system that was created back in the 1980s of sending electronic messages between devices which actually say what musical notes should be played. So if, for example, you've got a keyboard which you normally would play and it would play out of the keyboard's loudspeakers, if you plug a cable into a socket on the back, which is marked MIDI, you can then connect that up to other devices and it would send information about what you're playing across that cable. So on Able, I immediately went into one of the options at the top, and if you see in the middle here, it says use MIDI for bell sounds, and I clicked that, and sure enough, no sound came out of the computer's loudspeakers. Instead, you've got these messages coming out of the USB port on your computer. And I thought, well, this is absolutely marvelous. And so I started looking around about, what MIDI was all about. As I said, it stands for Musical Instrument Digital Interface. And you can use it for various things. So, for example, number one here is a keyboard. If you're playing something on a keyboard, you can send the messages across to, on the right-hand side there, a computer. So what you're playing could be, for example, recorded by the computer, or it could be played out of the computer's loudspeakers. Number two, here we've got a MIDI file of musical information, a song, if you like, within the file within the computer. And this is being sent across to loudspeakers. So you can play something out of a loudspeaker. Number three, this one on the right, actually, this is supposed to be a church organ. It looks more like a bed floating on water. So here you've got an organ console and it sends the messages across. A few years ago, I was talking to some people installing a new organ at Bray Church, where I used to ring. And I said, how does the information get across from the console to the organ pipes? And they said, it's a MIDI interface. And they showed me the cable, which was like 5 wires, 5 small wires for all that information. And number four is how I'm using it. So we've got Able on the left-hand side, and that's sending the messages out of Able across to the robots. So question is, how does that information get across to them? And so I started looking on YouTube in particular, and I found quite a lot of information about it. So I found out that I needed to build a MIDI circuit. I I looked for one that had all been built for me, but in fact I had to build it myself. So I had to sort of learn how to solder and things. But that MIDI circuit on the left-hand side there is like the socket from the cable that comes out of my laptop. And then there's about half a dozen components there, sort of resistors and transistors. Well, I just followed somebody else doing it on YouTube, step by step. And then about this time, my son, who knew I was building these robots, he suggested I looked at the Arduino. Now, the Arduino is sort of an electronic board, which is very good at switching things on and off. I'll demonstrate one to you in a moment. And what happens to this is that the MIDI circuit sort of translates the messages, sends the messages out to the Arduino, and the Arduino then has some code in there which splits up the messages to send them to the right robot arm. And so I built this control box containing these two components, and this is what it looks like. You can see it in real life in a moment. So that's the box at the top there. And inside the bottom picture, it looks a bit of a mess, mainly because there's a lot of wires going off to these sockets. These are the sockets that the robots are connected into. But the Arduino is sort of hidden behind these green boards in there. So that's the control box. Now, if I just stop the presentation for a second, if I can manage to do that. There we go. Right. Okay. So I just want to show you the Arduino board. This is a blue one, actually. They come in slightly different sizes. But this is key to it because as well as having an Arduino in the control box, there's one, or there's two in each robot. There's one for each arm, which controls when the motors kick in. Well, I'll just explain how this works. You don't have to worry about all these components in the middle, but the key things are, we've got a socket here. This what, when you're programming this, you program what you want the Arduino to do on your laptop, and you plug it in there and you download it onto a chip here. And once it's been downloaded, you can unplug it and it's standalone. You don't have to do anything else to it. And there's lots of what they call libraries of information. So a lot of things that you want an Arduino to do, it's already been written for you, and it's very good at switching things on and off. So for example, if you go into a museum and there's a light show display or a shop display with lights coming off and on, it could be controlled by an Arduino like this, and you can do all sorts with them. You can connect it up to temperature sensors, you can connect it up to the interface and Wi-Fi and so on. So I downloaded a bit of code which switched this little light bulb on and off, and as soon as you plug it in, there we go, it switches the light bulb on and off every half a second. And so you can see it's very clever at really sort of switching things on and off. And also we have around the edge here, we have all these little sockets, tiny sockets. And so I've got one of these going off to each arm, and it quite simply takes in the messages into one of these little sockets, and the code inside here decides which bell needs to be rung at that time and sends the message out through one of these other ones. So that's the Arduino. So what we're going to do now is that we're going to just have a quick look at the setup, and I'll ask Richie and Rosie to ring something for us. So here we go. If I can show you first of all, this is the, get it straight. This is my laptop, which I'm running Able, and next to it is the control box. And I've only got two robots at the moment, so I've got two wires coming out of it, and the wires go, well, they go up in the air actually, round, back down again into the robots, into the back of the robots there. So what I'm going to do is I'm going to so this is set up to ring some minimus. So I'm going to choose a method. Let's choose reverse Canterbury pleasure. And if I start them off,
A reverse category.
Ah, good. I'm pleased they behave themselves. Just like real ringers, they sometimes have off days, but they seem to be behaving themselves at the moment. So, right, we move on now to the construction of the robots. Just need to share my screen with you again. So, when I first started looking at this, I thought, well, I would build the robots out of wood, mainly because my workshop's mainly geared to woodworking. But I realized I needed a bit more accuracy than that. I also looked at Lego bricks, actually. I remember going to Legoland in Windsor, and there was a band of people playing on a bandstand. They were all made out of Lego bricks. And then I realized it would be far too expensive and too heavy. And then I realized that something like Meccano, which I used to use years ago, would be best. You can't get Meccano or anything now. And I also looked at angle iron, which would be quite a good thing to use. But eventually I came across this construction material called Actobotics. I was hunting around, and it's designed for making robots used in homes and in schools. And I've just got a short video now just showing what Actobotics is like.
Hello everyone, and welcome to a very special Friday new product post. As you can see, we're in a different venue this time because we actually have the most new products we've ever offered here at Sparkfun Electronics. We've got 470 new products. These are all from the Actobotics product line, and they're all robotic products. We've always carried a few robotic components here at Sparkfun Electronics, but we've never really carried anything as big as this. The reason why we chose Actobotics is because all of these different components work well together. So you have anything from gears, pulleys, hubs, we've got some shafts, we've got tubing, we've got wheels. All of these things work together easily, so you don't have to pick and choose from different places to make sure things work together.
Just stop that for a moment, and I can show you a partly built robot. So this is one that I'm currently building. So you can see the robot's arm here with the bell on the end. All the construction is made out of Actobotics. And these are the motors, 2 motors per arm. And the motors control the bell by this. You can see this here. This is the motor, and it turns this threaded rod. And on the rod, when it's made, there is a nut which runs up and down the threaded rod, which actually makes the bell move up and down. So that's the main sort of construction material. But the key thing, which was the thing that actually made this quite difficult for me, was the action of the arm. So if I just move back to this again. So the actually fitting the arms and the motors together was really quite tricky. The main thing was making sure that it looked realistic. And I've got a video here of ringing. This is actually at the College's dinner. And if you look at Ollie Cross on the right-hand side, which actually shows the action of the arm, and I found by slowing down videos that I made that there's sort of 3 points where I could build the motors in. One of them is for the shoulder, one for the elbow, and one for the wrist. In the end, I decided that the actual shoulder movement I could dispense with, and so I ended up with 2 motors, but they don't sort of start at the same time. At the hand stroke, when the bell's going up, moving upwards, the wrist actually starts off a little bit later than the elbow, but at the backstroke, they both start coming down at the same time. So what I was able to do was to program the Arduino so that they actually kicked in at the right time. So I'll just play this just for a few seconds.
It's okay.
So that sort of showed the sort of also the accuracy of the striking that I wanted to try and achieve with the robots. The motors, I completely sort of underestimated the power needed to ring these bells. I started off experimenting with some really small motors, which really didn't work very well at all. Because the problem is that when you're ringing, you're actually starting off very quickly and stopping very quickly. It's sort of a sudden sort of jerk. So again, I was hunting around on the internet, and eventually I found these ones which are called ClearPath, and they have they're very powerful, and you can program them. And this video coming up will actually show how easy it is to actually program them with speed and acceleration and so on. In the demonstration, the motor is on the right-hand side. You can't quite see it, but it's connected to a belt which moves a carriage backwards and forwards along a track. So you can see how quickly it can actually start off and slow down.
ClearPath Operational Mode 2. Move to absolute position, 2 positions. Move to absolute position, 2 position is the mode to use when you want to smoothly move back and forth between 2 positions that are referenced to a home position sensor or switch. To use this mode, open the ClearPath MSP software and configure ClearPath with your motion parameters: speed limit, acceleration rate, and RAS, which is Technic's automatic jerk and jerk derivative limiting feature that creates very smooth transitions in the motion. Next, define your 2 endpoint positions. These are relative to the home sensor position.
So that let me program the motors so that they will actually start and stop exactly the right place. You know, with a motor that's in, say, a vacuum cleaner, as soon as you turn the power off, it just carries on until it slows down. I wanted something that we could actually, you know, really stop it in a precise place. So then I had to decide how I was going to transfer the power from the motor to the arm. And I started off with cogs. And this next video shows an early prototype. Here, the motors are horizontal, and I'm using these cogs. And this didn't work very well at all. I only had 1 motor per arm, and it gave a very sort of stiff, sort of tin soldier sort of action. And also the cogs were very noisy. And this next video shows the sort of final solution I came up with, where we've got 2 motors per bell, using the threaded rod to actually transfer the power to the bell. And you'll see how much better this one is. So having decided how I was going to build the things, I built a robot with just one arm. So we can see a bit of ringing here on this one. This is ringing playing Bob Doubles, I think. Go. And so we come on to the future developments, which I just stopped the presentation. That's the end of the presentation on the PowerPoint slides. So I just want to show you 1 or 2 things I've got in mind. This is a little LED matrix display where you can display any characters, numbers, and so on across here. So the idea is this will be will show the actual number of changes being rung. So as soon as the conductor says go, then it will actually count up from 1, show the number of changes. I've also got this board here. This one I've sort of partly got working. The conductor will be able to talk into this microphone to say bob and single, and then the robots, they will need to know which method they're ringing in advance, but this will in fact allow you to make up a touch as you go along, and the robots will react accordingly. So from here, the board here interprets what you're saying and sends the appropriate signal to Able, because Able's got an interface for bobs and singles. Also, I'll be able to put some software into the control box to adjust the strike, and if needed, I can sort of slow the signals going out if I need to. I thought a bit about what happens if a bell is a bit slow and you want to ring it a little bit quicker. Well, obviously you can't send out the signal before the signal's arrived from Able, but then of course what I could do is just slow down all the other bells. So that's a possibility. I've got enough parts to make another 3 robots, which I'm planning to do this year. And probably one of the most interesting things I thought of is to have a switch, foot switch, and as you press the switch down, the robots start to go wrong and they start firing up, you know, they start going wrong. So it's really good for conducting, practicing your conducting, and as you take your foot off the switch, they gradually get right again. So there we go. So finally, Catherine's going to ring with the robots, some minor. So if I just get ready for that, and then that will be it, I think. So, okay, we've got your bells. So I can hold the camera, and so on the Able here, I've just got to change this to 6-bell ringing. I can do that. And we've already got a touch of plain and little, which I will, if I can see where that is. There we go. Plain and little minor. So here we go.
Name Bob. Lucky Bob. Name Bob. Little Bob. Name Bob.
Good. Well done, Catherine. Well done, robots. It's really good.
Great, thank you.
Right, okay, so there we are, Arthur. Here we are, we're all done.
That's great. Well done. Well done. Thank you,
You're
Catherine.
welcome.
That must be the most nerve-wracking bit, mustn't it?
Yes, ringing live. Yes. Yes.
No
Yes.
mistakes from humans or robots.
No, that's right. Well, we had a bit of a little practice this afternoon, and Richie was deciding not to perform particularly well, so obviously needs a couple of screws tightening up or something inside.
Well, I think sometimes I feel like that when I'm
So-
reading. Thank you ever so much, but both of you. Thank you for that, Catherine, and thank you, the robots, and thank you, Graham. That was great. Just to remind people that if you do have any questions, obviously either furiously type them into the chat box now, or unmute yourself, and then I'm sure we'll be happy to answer those. But Graham, actually, I did have a question, and I think you might have touched upon the answer as you were talking just then. But you talked about sort of off days and Richie having an off day. What causes those off days? Is it loose or?
Yeah, it's I've had this time and time again when I'm developing them, and they're mainly caused by loose connections and things like that. And it's quite interesting, really, because although I've built it and I know how to run it, it's not the sort of thing that could be put into production just now, because like all IT developments, to develop the sort of the basic functionality is very straightforward, but it's all the error conditions and the things that can go wrong you need to actually build into it. So, for example, just give an example, if I turn the robots on without turning Able on, so there's no Able input, the input is unstable. So it effectively, although you think, oh, there's nothing there, but in fact, the bells will just completely ring randomly. So as soon as you actually lose a connection to Able, then you'll find bells will sort of flying up and down the whole time. And it's small things like that. In fact, the Arduinos in the robots, they're actually running on these just on a 9-volt battery at the moment, just like this. And I mean, ideally that should be provided by a power supply, into the mains. And at one time when I was developing it, one of the arms just wouldn't perform. It would sometimes work and it sometimes wouldn't. And then another one would start going wrong. And what was happening was the batteries at the factory run down. And I didn't realize until someone said, if you use a battery to drive an Arduino, it won't last more than 24 hours. And probably all the testing I was doing, everything else, it was just running out of power. So yeah.
Juice. They don't need their food like we do, but they need
yes,
their
exactly. Yes, yeah, that's right.
Okay, a couple of things have come into the chat box. I'm just going to go through those, if that's right. So Derek says, first of all, very impressive. Thank you for showing your developmental process. In your demonstrations of plain Bob doubles with one robot, how is the system getting the information from the other 5 bells? I cannot see any wires from the sensors on the human operated bells.
Okay, so in fact, because I'm using able to drive the robots, they don't stop for anything. The humans are ringing round the robots. So if you notice when Catherine was ringing them just at the end, when we started off, because she was ringing the trebles, Catherine was ringing the trebles, we had to let the robots ring for a whole call to start with, so that Catherine knew when to start. So effectively, the humans are actually really just ringing around the robots, and the robots are ringing at a constant speed. So if you're learning to ring handbells, usually the people ringing with you are very kind to you. So if you hold up a bit, they will wait a bit for you. But if you're learning with the robots, they won't stop. And in fact, one of the things, once you get more experience ringing handbells, you learn to ring to a rhythm rather than ringing after people. So effectively, you're not holding up. If the person in front of you is a bit slow, well, you just ring at the right place according to the rhythm and not wait for that person, because as soon as you do that, it completely destroys the rhythm. So even if someone's completely lost, all the other bells will just carry on, and it will just carry on, ringing correctly. So the robot, the one-armed robot, effectively just stand alone. It will ring by itself to the right rhythm.
Super. And that answers a couple of questions came in about sort of speed and who sets the speed. Actually, I think you've answered that.
It is able. Yeah, it is. You set the speed in able to start with. Yeah, that's right.
Super. Keith asked, what maintenance do they need?
Not very much. I've got some silicone spray which I spray onto the bearings occasionally. So that's about the only thing I do at the moment. I would like it to be a little bit smoother than what it is. Excuse me, Catherine. This is the threaded rod which is used. So the motor is connected down to one end, and the arm is connected to the other. And as the motor spins round, the threaded rod goes up and down here. And these do make a bit of noise. And it would be better if I had something which wasn't quite so noisy. This is brass at the moment. You can change them to plastic, which might be better. So there are some sort of changes I perhaps would like to make. So when I'm building my other 3 robots, I might sort of experiment.
That sounds good. So thank you for that, Alison. I'm again talking about sort of tweaking things, and yes. Alison says, have you tweaked the clappers in the handbells on the robot so they strike just once and at the correct time? Yes, I did. And in fact, that was the biggest problem I had. In fact, I had to, the springs inside the handbells, which just hold the clappers off the bells after it struck. I had to make quite a lot of changes to those, and what I'm finding now is that when I'm taking the handbells off the robots to ring with real people, I'm constantly bending the springs, which isn't very good. One time actually, I had this idea that I would abandon real handbells and use the e-bells that were shown on the video earlier on. So these are plastic bells which are connected to your computer through a wire. I had this idea of actually taking an e-bell and in the top of it putting in a loudspeaker. So if you like, it was like a standalone bell,
So it would, as you ring it up and down, the sound would be produced electronically out of this loudspeaker. And of course, that would avoid any problems with clappers. But when I mentioned it to Graham John actually, and he said, well, it will actually sort of take away the excitement of actually seeing robots ringing real handbells. So I've sort of abandoned that idea. Yeah.
Super, thank you. Susan is asking about the repertoire of the robots, presumably that they can ring whatever whatever's in Able.
And that's the beauty of it. Able can ring any method, any composition, and so it's very easy to actually program. Just pick out a new method, and you can just ring anything you like. It's really, really good for that. Yeah.
Excellent. Very clever robots.
Yes.
Jonathan says he's talking about the technology now. So does one need a high-end laptop to run it all? So how powerful is the?
No, it's just an ordinary laptop. I don't think it needs. If you can run Able, then which I think most laptops you buy today will run Able. Able is, if you don't know, is you just download it. I think it's £20. And you've got a copy of the software, and you can run it on any laptop or a desktop for that matter, yeah, or a Mac, yeah.
Super. Again, I think we're coming to the
Yes.
end of the chat questions, but the last couple. So Derek says you kind of get able to give you a score, and perhaps that's a good thing, maybe.
Yes, yes, that's an interesting point actually, because yes, I know you can get able to give a score. So if you're pressing keys, you can actually get the score up, and it flashes up as you ring, green or red or amber, I think it is, as you go. So in this particular case, I don't think you can actually do it with the robots, because the robots are, I haven't seen it on the screen. And of course, in theory, they should be ringing at the right time. I mean, the signal leaving Able should go out at the correct time. So, but in fact, the striking like today wasn't perfect, actually. I'm not quite sure the reason why, because it ought to be. And I found that putting a larger bell or a smaller bell on the end of the arm didn't really make much difference to the striking. So it's something which, that's why I thought, well, perhaps on the control box, I can have little knobs which control the striking, both hand stroke and backstroke. So I can make them strike a little bit quicker or a bit slower, perhaps. I could see how that could be done. It's just a bit of time sort of building it all. But yeah, that's possible.
Super. There's a bit of chat coming in terms of like thanking you both. So so please have a look at that in a moment. And Derek's got some advice for you around, or potential advice around ball bearing lead screws.
Yes.
That could make things smoother.
Yes, lead screws. Yep. Okay, I'll have a look. That'd be great. Thank you.
Super. You don't have to answer this mischievous question, perhaps, but do you prefer ringing with the robots than humans? Are there benefits to it, or do you miss human contact when you're ringing?
Oh, I see. Well, yeah, I must. Yeah, I think actually one of the beauties, I think, one of the things I really like about ringing handbells as opposed to towbells is that it is quite a sociable thing. I mean, obviously, if you go. You go to your tower and you go to a practice, and then you go to the pub afterwards. That'd be great. Handbell ringing, happens in people's houses, and so you're traveling to their houses. And typically, we were ringing a peal every Wednesday night for many years, about 40 years. And we'd have that, and then afterwards we'd have a meal together, and so it was quite a sociable occasion. So. Rosie and Richie haven't volunteered to make a meal for me yet, so perhaps they will at one time. Perhaps I can train them to do that.
Yeah, that could be the next thing. Chores and meals. That could be.
Yeah, that's right.
Super. You have to cover their ears before you say anything like this, though.
Yes.
All right. Just before we sort of say our final thank yous and call tonight round, so to speak, I'll just put in the chat box our sort of Google Drive of future talks. So again, have a look at those. And everyone's very welcome to any of the talks. The links tend to come out sort of a week before. So next week we have Mark Regan come to talk to us about the bells of Bow. So that's be a fascinating sort of historical talk. And the week after that, actually, we don't have a talk on a Wednesday. We have a sort of Easter break, but on the Friday we have a beer tasting session. So That should be joined by Hayley Young there. Susan, you might have to ask your dad if you can get some zero alcohol beers in if you want to join us for that. All right. Graham, Catherine, there's lots of thanks coming in the chat box, so please make sure you have a read of that. I think
Okay, we will do.
I just saw something come through saying it was, ingenious, and I think I definitely echo that. Sort of seems to be a labour of love and a perfect project for this period of time. When obviously you can't ring with others so easily, although hopefully that will change very soon. It just seemed to me such a clever invention, and maybe we'll see Rosie and Richie at college youth dinner at some point doing their hamburgers there.
Yes, they're too young to join the colleges. I'm sorry.
Yes. All right. Thank you ever so much. I will stop the recording and then actually give you a chance to have a quick look in the chat box, and then we'll sort of call tonight.
Thank you very much. Yeah, we've enjoyed it. We've enjoyed it. Thank you.